Be sure to watch this video until the end, so you'll be able to solve this problem in an interview without any problems. The problem statement here is really good. Once again, we'll use the fishing method that I use. Right away, we're told that we have an array of numbers, and you need to move all the zeros to the very end of the array. But at the same time, you need to preserve the order of the numbers that are not zeros. So here too, the example is very clear and illustrative. So we have 0, 1, 3, 12, and in the end, we should get 0, 3, 12, 0, 0. The problem statement is very clear. Sometimes they can be complicated, but in this particular problem, I really like how the conditions are presented. The entire and comprehensive solution to this particular problem is meticulously structured so that we will effectively have two distinct pointers that will progressively move through our given array. And with the strategic use of these two important pointers, we will then proceed to carefully swap the numerical values around within the array. We have the first pointer, write, which is read, and the blue pointer, read. The algorithm will consist of placing these two pointers on the first element. This right pointer will always be at the position where there is a 0. Let me show you. So, this is where our algorithm starts. We only move the read pointer until we reach the point where we need to swap them. So, right now, here's what we have. The first pointer is pointing at 0, the second pointer is pointing at 1. We've reached the moment when we need to swap them. Swap 0 and 1. With code, we swap them. So we do it like this. And we move the right pointer to the 0. Next. And the read pointer was already there. At this position. And it starts moving further. It moves on. And now we have 0 and 0. There's no need to swap them. Next, we move the 3. There. And again, we have 0 and 3. We swap them. Like this. And we move our right pointer one more step. So now the right pointer is again at 0. And the read pointer keeps moving forward. Move the read pointer. And again, we have the same condition. When we need to swap them, we swap them again once more. And move our right pointer. And in this way, we've moved both the read and write pointers all the way to the end, and we've ended up with this result. With this algorithm, we can achieve the goal of our task. We've done the first step, we've understood the conditions. We've done the second condition. I've shown you the algorithm that solves it. So let's move on to the third condition. And to solve this problem, let's write the actual code. So we've solved two pieces of the puzzle together. Let's keep going. Now let's take a look at the actual solution. So as I already mentioned, we will have a separate pointer called write. And it will always point to the place where we move the elements that are not zeros. That is 1, 3, and 12. Move them to the place where we have this write and read pointer. So these are two pointers that will move through our array of numbers. Next, we start a loop like this, which will allow us to have access to the indices. So here, read will be the index itself. This is very important because there are different types of loops. Sometimes you have access only to the value, sometimes to the index, and sometimes to both the index and the value. Here, we specifically use this kind of construct to have access to the index. So it will be 0, 1, 2, 3, 4. These are exactly the indices we need. That's it. And next, what do we do? So we've started the loop. And next, we're going to perform a check. Here, pay attention. I'm giving you a very important tip. When you have some kind of pointer with some logic and you've initialized it, at the very beginning, always make sure not to forget that it needs to move. So, when you initially start the loop, one of the primary pointers, in our specific case, read, will automatically move forward. It will proceed automatically diligently going through each and every element within the collection. However, the additional pointer that you explicitly create will inherently require some specific condition, some particular state for it to effectively initiate its movement and progression. So this is an important rule. If you have two pointers, don't forget that both of them must move in some way. And in our case, we'll have this kind of structure. If the value at the position where read is located is not 0, so for example, right now, if read is at index 0, the value is 0. So we don't go here, we move. That means we indicate our view further here, and then we subsequently get the precise meaning. Here, specifically, read and I are considered equal to 1, and we then fall into a complex knot, and here we carefully change their respective places. This is, once again, a fundamental construction in Python when we effectively make two distinct elements. On the left, it's clear, and on the right, it's clear what to put in these places. If you write the algorithm in Kotlin, Java, JavaScript, and so on, you might have a different way. There will be some other way to write this code, but this is the way it's done in Python. I like that. With just a single line of code, you can swap elements. So we've dropped down here, and right now we're here. Our read pointer is here. And what are we doing here? We effectively swap the one with the specific element where write is located, and then the element where write is, we subsequently swap with the element where read is positioned. This is because write is always where we consistently have 0, and once again, we simply take it. And we then place this particular element here and this other element here. That's precisely how we can effectively shift these crucial things. After that, our right pointer meticulously moves one significant step to the right, and we then carefully take it and deliberately move it over here. So with this particular kind of precise manipulation, our right pointer will consistently and reliably always be positioned at 0. And then it moves again. Here we have 0, so we don't drop down here. And we keep going. We land on the element 3, so we can use this swap again because 3 is not equal to 0. And we swap them. The 3 goes here, 0 goes here. And in this way, all our zeros will gradually move to the end of the list, while the elements that are not zeros will keep the order we need, 1, 3, 12, as in the original. And with that, we solve the problem. If you want to get additional materials on this problem, be sure to follow the links below, subscribe to my channel, and leave a comment. What other problems would you like to see covered?